Hello my friends and welcome back. A 555 timer is a pretty versatile device and today we are going to build a project around it. It usually comes in an 8DIP package and here's how it looks like. We are gonna need other components like a 4.7k ohm resistor, 100k ohm, and two 10 ohm resistors. And also a 100 nanofarad and a 10 nanofarad capacitor. We are going to need a multi-vibrator configuration, whereas R2 equals 100 plus 10k which is equal to 120k ohms. ZAR1 equals 4.7k ohms and C equals 100 nanofarads. This arrangement of the multi-vibrator will give us an approximation of 60 Hz square wave at pin 3, which is the output. So let's make it. After soldering the schematic in the midair, it was time to test the output waveform on the oscilloscope. The output is obviously a square wave with a frequency of around 58 Hz, which is pretty very close to the 60 Hz which we have to get theoretically. So, I spent some time to focus the frequency signal delivered at the output of the 555 timer onto the cables of the oscilloscope so that there is no much change from the 58 Hz that we had got, because a bigger change would be so different from the output frequency of the AC main sockets. Then the next step, I rewinded a small transformer from an old switch mode power supply circuit, and then came up with its new primary and secondary turns as you can see. I then brought out all the required components for this project. But before we continue, take 1 second to click that subscribe button below this video so that you don't miss out on my other upcoming videos. Are you done? Alright, let's continue. In the next stage I connected the circuit so as to make a simple inverter. The bulb then magically lights up. This is due to the MOSFET that switches on and off 120 times every second due to the 60 Hz signal applied to a gate terminal from a 555 timer. But warning, this circuit produces around 240 volts AC on the output. Don't touch the terminals of the transformer as this could harm you so bad. And if you don't have much experience in electronics, do not set up this circuit. After all this, I wanted to make this project even more appealing after watching someone else do the same on the internet. I first dismantled the setup by disconnecting the battery, MOSFET, transformer and the 50 Hz generator circuit. To do this, I got an old spoiled phone charger and unscrewed its terminals in order to open it. I then went on to remove the top part and then followed by the inside circuitry. In the next stage, I embedded all the inverter circuit with the exception of the transformer because it was a bit larger and couldn't fit in the charger housing. So I utilized the small transformer that is already on the PCB of the charger. I then bought a new smart charger cable and cut it in the middle so as to expose the 4 inside wires. I tied the D+ wire and the D- wire with a sellotape and then turned my attention towards the positive wire and the negative wire. I fixed the circuit inside the charger housing carefully and checked to see whether there are any misconnections. Then, I placed the charger top cover back and fixed it by screwing back the 2 screws using a screwdriver. Connected the earlier cut USB cable to the charger and then the corresponding positive and negative wires. I connected them to the 9 volts battery plug. I utilized the black sellotape for the most parts. Connected a strong wire on one of the legs of the charger and added a small piece of sellotape to keep it firm. After all the setup is complete, it was time to do the final test. I connected the battery to its plug so as to power up the circuit. And then finally connected the bulb at the output. Nothing goes wrong and the bulb lights up with ease. Did you learn anything? Don't forget to like, share with your friends and also leave a comment or any questions down in the comment. Also subscribe to this channel so that you don't miss out on my new upcoming videos. This also shows your supports towards the channel. Stay creative and I will see you next time.